What's up, bosses? I'm JoeMan543. Welcome to this odd Wednesday stream where we're going to be doing math. Yeah, I just don't know why you're on a stream for math. That's kind of lame. But yeah, long story short, I'm a college student. I have been for several years, and part of the degree, obviously, is math classes. I don't know of any degree that doesn't include math classes. And so, obviously, eventually, I need to reach a certain level in math. In my particular degree, I need to get through physics, which requires calculus, which requires pre-calculus, which works its way down. So there's two ways that I can get there. First option is I start from the lowest class that they'll allow me in without a test score, because it's just been so long. Anything I had has expired. So start from the bottom, work my way up. Or study a bunch, take a test, test high, and then get into a high enough class that I don't have to work up through a bunch of classes. So that's what I'm trying to do. That's why it's summer, but I'm still doing math. So the goal is to get enough math done, score high enough that in the fall I can jump up to pre-calculus. So it'll just be pre-calculus, calculus, and physics. Just 3 classes, knockout for the degree. Easy as that. So that's why we're doing a math stream. Also, I guess the other reason why is because I posted on my Discord, hey, would you guys watch a math stream? And at least 9 people, is it still 9? I'm going to check the number right now. No, at least 10 people said that they would watch a non-Friday stream for math. Would you watch a non-Friday stream of me doing math homework? I am going to I'm going to call out those people. George Geo, Ender, Movie, Give Me Your Coffee, Cessa McKee, Delta Spoon, Destroying Your Net, and Bread, Butane. Yeah, so you can blame those people for why we're doing a math stream. Anyway, speaking of giving people call outs, I'm going to welcome everyone that's here at the beginning. Don't know why you're here. It's a math stream, but yeah. Welcome, Nutdoge Halo, Destroyer Net, George Dewson, Noobified, the last psychic vampire elder. For a moment, I thought that was physic. What, last physical vampire? I don't know. Mr. Retard Dinosaur. Math! Yeah. DGC Pictures Entertainment. This is so in character for you. Math, Joe Man! Yeah. It's the Joe. What's your degree? Computer science. Thomas Silva. Leon Dewsbury. Yes, welcome. Okay, so yeah, we're not going to be playing games. I'm not really planning anything exciting for this stream. The crazy life of an idiot. I don't know why I'm here either, but here we are, yeah. So, I mean, let's get into it, right? Let's do some math. So, let's see. I'm going to go to my screen here. Actually, I'm going to show me here. We'll figure this out. Some way to show what I'm writing, because I write the problems down. That's important things. And then obviously this is the math to learn. So yeah, prep for pre-calculus, calculus, physics. That's what I'm looking at. Timeline. I can see what I've done. Can I go to last week? No? I can only see what I've done this week. Okay, so I did 3 modules yesterday. It's like 2 or 3 math problems per module, so we'll probably get a lot today, maybe 20 or so. But yeah, a lot of math to do. We'll continue my path here. This is in a system called Alex. It's just like a math preparation system. So normally how it goes is, here's how you do the thing. Start. And then it tests if I can do the thing. So, I only have one webcam. Do I? I don't know where my other one went. I don't want to dig it out. So what I'm going to do is kind of prepare my desk here, and I'm going to angle this down. No, that's going to be upside down. Hold on. I got this. Haha. Hold on. That might be backwards. Let's see. So I've got some math from before. I guess, do you guys want to see the math or see me? It'd be weird if you wanted to see me, like, here for math, right? Okay, so, and this is gonna be incredibly small. Hold on, I got this, I got this. Boom. Math. I also know that pencil doesn't show up very well on webcam. I could probably use a pen, actually. Yeah, we can just do like half size, and then we'll drag this over. So, okay, so if we'll do the practice here. I want some Joe Man Math ASMR. Joe Man, I'm in 5th grade. I don't know this math. Okay, this is well, I guess, yeah, what is this? Let's actually do some learning here, right? Okay. So, find the greatest common factor of 12y cubed and 8y. So, the greatest common factor of 12 and 8 is 4, right? So it's like, what can you divide these by? Or like, what's the biggest number you can divide the numbers by, right? So 12 and 8. All right, let's start from 1. Okay, obviously you can divide by 1. That's always an option. Can I divide by 2? Yeah, I would get 6 and 4. Okay, can I divide by 3? I can divide this one by 3. I can't divide 8 by 3. Well, I can't divide it by 3 and get a whole number. Okay, can I divide by 4? Yeah. 5, 6, no. Okay, so 4 is the biggest one we can get, and that's what it's getting at down here. And then we take y. So y cubed and y is just y. If we had y squared, I think that would be the greatest common factor of that. So of our numbers, we got 4, and of the y, it's just y. So we combine that together. Our greatest common factor is 4y, and that's what's getting at right here. So also, hopefully, by like explaining it, I will learn it even better. So plus for me. Heli Vargas, hello from Argentina. Oh, hello. All right, let's actually start with some real math here. And I do have a pen if this just doesn't show up. But I like pencil because I make mistakes. All right, so we got 4b cubed. It's a little hard to see. Do I do want to actually make this visible. I'm getting further from the microphone. I think I have something that might help. If I can find it. Nope. Huh. Well, I thought I had a little stand or something. Yeah, because you probably can't like hardly even see that. Let me try this in pen. I could try writing a little bigger too. 4b cubed. Okay, that's kind of visible. All right, 4b cubed and 10b to the 4th. I guess after cubed, they just sort of run out because we run out of dimensions, right? 4th dimension is like time or something. I don't know. All right, so we take these numbers. Obviously, we can go by 1, but we can also go by 2. 3 is not an option. 4 doesn't really come out of 10 very nicely. So we have 2. And then of these b's, it looks like b3 is the greatest common one. Unless b squared. Ooh, that's a good point. Because when it comes to exponents, would it be, well, it's definitely a b. When it comes to exponents, do we take the biggest exponent, which would be cubed, or is it like the biggest divisible one? The example didn't really cover this. Oh boy. Oh yeah, let me see if I can focus the webcam. That's a good idea. Well, that seems to be about as focused as it'll get. Oh, webcam's falling. Okay. Here, I have another idea. I have a water bottle here. Okay. I'll put the webcam on the water bottle. Yeah. See my microphone there. Okay, that is way better. I'm just gonna sort of jam this on the water bottle, I guess. All All right, and then that's way zoomed in. So now I gotta do this whole zoom out business. That was okay. Welcome to the stream where I figure out how to stream. Yeah. Get the edges of the page here. Oh yeah, that's way better. That is way better. Okay, and then, well, if I expand this out, that's just gonna take the whole screen. Ooh, here's an idea. Okay. Yes, we do the whole screen with that, mostly. But then, we put display capture on top. We're gonna crop this one down a little bit here. Okay. No, because then that one's going to get small. Whatever, you don't need to see that. Yeah, we're just figuring out how to stream. Because apparently I still don't quite got this. Okay, that's good enough. Yeah, let's get back to the math. He's changing the pen. Alright, this looks like algebra. I don't really know where algebra ends, but we've definitely entered algebra. Okay, we were trying to figure out, we got the 3 here, we got the 4 here. Exponents, like if these were normal numbers, 1 would be the only common factor between them. But because they're exponents, that's where I get weird. So I'm going to guess 3, and if I'm wrong, it'll tell me. So now we've got to actually enter our answer here. So 2b, it's a little awkward typing on my keyboard, reaching around this bottle that's holding up my webcam. Okay, 2b to the 3rd, I think. We're gonna find out. Check. Correct. Okay. So when we got. I just ruined that 3. We got 3 and 4 here. When they're exponents, the greatest common factor is 3. When they're just regular numbers, you have to actually like go the normal way. This is why exponents and regular numbers suck. Okay, we'll move on to the next problem. That was correct. All right, greatest common factor. See, I always write the problem down because that's just how I roll, I guess. Canimax, welcome to the stream. Just doing some math here because I'm a college student and I'm learning stuff. All right, 3, then we have 15M. All right, so 14 and 15. I know 15 only has 2 factors that go into it. There's 3 and 5. 14 has 2 and 7. Nothing in common. So it's just going to be 1, which, because we're going to be doing like M, that doesn't even matter. Get rid of the 1. You can get rid of that. And then M to the 3rd and M. The only common factor here is M. I'm fairly confident about that. We're gonna find out if that's true. Check that. And that is correct. Yeah, 14 and 15, they got nothing in common except 1. But because we have M here, forget about the 1. The 1's implied when you have M. And then exponents, M to the 1 and M to the 3, again, 1 is the only thing in common. So it's just M. Okay, and because we got 2 in a row, it's kind of falling off the screen here. It's like, whoops. It's like, yeah, keep it up, woohoo! And then we can continue on to more stuff. Yeah, I still don't know like the best way to do this, but I don't know, we're trying. Okay, we're at the following without an exponent. So, oh, negatives, I love these because I think they're actually pretty simple. You just sort of do some flipping, right? All right, for any non-zero rational number, you take your fraction and your whole number, and we have the following. All right, so it takes the negative here. You have AB, BA, and then that's not negative anymore. It's literally, you just flip it, as long as it applies to both of them. If it's above They'll probably get to that in a later one. But yeah, so you got this negative up here, 2, 9, boom, it's 9, 2, squared, and then because parentheses, you know, PEMDAS, you just square both of them over each other, and if that could be simplified, it would. Can't be, so, okay. Let's start this one. Is this college algebra or algebra 2? I don't even know, man. It's preparation for pre-calculus, though. So, yeah. Okay, so forget this stuff up here. We're going to work a little lower here. All right, so I always write out the problem. 5 over 4 to the negative 1. Oh, this couldn't be easier. I don't even need to write this down, honestly, but whatever. Yeah, so we just do a little flippy-do. That simply becomes 4 over 5. I'd write the parentheses to the power of 1, but, like, that's pointless. So, yeah, it's just 4/5. Simple as that. 4/5. Yeah, negative exponents, super easy. They literally just flip the thing. We use scientific calculators for these problems. I mean, I got a TI-30 if I need it. I got a... I got a TI-84 if I get really desperate, but like, nah, man. This is easy math. 4/5, it's nothing. It's single digits. Okay, we'll continue on here. All right, so we got 7 over 4 inside parentheses to the negative 2 power. Again, we do our little flippy-do, but it's still in the parentheses to the squared. Here, we'll help separate this with some equal signs. Just got my flow going, you know? All right, so 4/7, but then we need to square both of those. I normally wouldn't write this out because I just, in my mind, I know squared, that comes out to 16, and this one comes out to 49. When I generally know single digits times single digits easily off the top of my head. Once you get to double digits, I lose you after about 12, but like 4 times 4, I know easy 16, 49, yeah. Those don't really simplify into anything. They don't really have anything in common, nothing to simplify. So that is the answer, 16 over 49. Boom, that is correct. And we got 2 in a row. So hooray, learning streak. It's cut off, whatever. All right, then we'll continue on here and keep learning. TI-84 is a lifesaver. Teacher 543, yes. All right, yeah. Gamer bread, welcome. Math. Okay, so what do we got going on here? The functions f and g. When you start getting f and g in here, this is where it steps up, in my opinion. All right, so f of x, which honestly, this is just y. Like, y equals this. Anyway, f of x equals 2x squared minus 3x, and g of x is negative 3x minus 3. So find f of negative 5. Really, so yeah, this x is in parentheses, and this negative 5 is in parentheses. F of x, f of negative 5. That just makes this x negative 5. So all the x's become negative 5. And then g of 7, same thing over here. This x over here, g of 7, g of x, all the x's on this function become 7s. So it explains down here. We just take this negative 5, swap x out. So negative 5 in all these places. Do your parentheses, because who knows what's hanging out around here. And then you just sort of math it out until you get a number. Same thing with g of x, math it out until you get your number. Then you have your 2 answers, f of negative 5, 65, g of 7, negative 24. Yeah. So let's actually do a problem here. Let's see, running out of room a little bit. I'm gonna a little precarious here. Put my water bottle on my paper. Like, you see the base of the water bottle right there. That's how close we're working here. All right, so can I focus this better? Actually, it's a little better, yeah. All right, what are we doing here? So, also, I don't know if anyone will ever care. If anyone thinks this is like cheating or anything, like, look, there's a million math problems out there. If you know any of them, you'll do fine on test. Okay, so I'm gonna save on some writing here. So 3x squared minus 3x. The x gets swapped with -3, so I'm just, yeah. I'm going to do the equal sign. I'm not going to worry about the left side of that. So 3 times -3 squared minus 3 times -3. All right, so that's going to be one of them. And then over here, we're going to have a -4. I can't really move my paper to whatever. All right, -4, and that is g of 4, so we're going to stick our 4 in there, minus 3, and then we just got to simplify these out a little bit. So, so PEMDAS, what do we do first here? So PEMDAS is the order of operations, is parentheses, exponent, multiplication, division, addition, subtraction. So first thing is parentheses. If there was anything to do inside the parentheses, we do that. There's not. Second is exponent, so this square is going to apply to that -3. -3 times -3, two negatives make a positive. I wish life worked that way. You get a 9, so we're going to have 3 times 9 minus, and then we have 3 times 3. Again, negative times a negative makes positive, so we're actually being plus 9. And then over here, we're going to take this -4 times 4, -16, minus 3. All right, next step down, 3 times 9, that is 27. 27 plus 9, I'll just keep skipping down, 36. And then -16 minus 3, that is -19. So, simple as that. So f of -3 is 36. And g of 4 is -19. Correct. Okay. Next one. Yeah, I should start like drawing lines or something. This is getting messy. Oh, that didn't even make a line. There we go. There we go. I'm gonna move down our page a little bit here. So, same deal. So, 3 of -7 basically, minus 3. Then over here we're gonna have -2, -4 to the third, minus 5. All right, then we just gotta math this out. So, all right, so PEMDAS. So there's nothing going on in here, no exponent. Multiplication is the next thing, so boom, it's gonna be -21 minus 3. We'll just keep going down here, -24. All right, jump over here. So this to the third is gonna go to the -4. So -4 times -4 is 16, times -4 again is 64, but -4 again. So it's -64. So we're going to have -2 times -64 minus 5. 2 times -2 times -64 is positive 128 minus 5. We have 123. So that's what we got. So f of -7 is -24, and g of -4 is 123. Hooray! It's gonna be really awkward when I get one of these wrong. Lucky me, I'm in a familiar territory right now. Eventually I will not be. PEMDAS. Please excuse my dear Aunt Sally. You know, they taught that to me, please excuse my dear Aunt Sally, but honestly just remembering PEMDAS like as a word was easier, so I just remembered it as a word. Yeah. The upside down pyramid of math. Yeah. Okay. Let's see. Do I still have music playing? No, I don't. There we go. Probably make that music just a little louder. There we go. Right. So we got to solve for W. Okay, yeah, this is familiar stuff. So there's our W. We just got to math around, toss stuff around so that W gets all by itself, and whatever is on the other side is on the other side. So got a W here. We have an 8. Let's strip the 8 away. So plus 8 to both sides strips that 8 away. But this one just got bigger because, you know, things are staying equal. And then we have our -3. So we're going to divide by -3. -6, W. Boom. And when you divide by a negative, this little greater than becomes a less than. Or vice versa. Less than would become greater than. So you gotta flip that. That is one little thing that I think trips a lot of people up when you divide by a negative. Alright. I'm gonna move down on my paper here. Make a line. Okay. And move down more. I'm gonna need a new page soon. Okay, so -5 minus 3x is less than 10. I've been doing this for a half hour. Wow. Alright, yeah, so we just gotta math this out. So +5 is gonna be the first thing. I'm not even gonna write the +5. I'll just know. Yeah, so -5 from this side, -5 from this side, so 10 becomes 5 because we took 5 away from it. And then divided by -3, so x is... Oh, see, I almost fell into the trap. No, divide by -3, so we're going to flip that. X is greater than 5 by -5/3. Because it's getting divided by 3, but we can't really simplify that, so it's just... It is what it is. Alright, so... X is... Gotta reach around like my microphone and all that on my desk. X is greater than 5/-3. Oh, not really. It's when a negative gets introduced, the whole thing is just sort of negative. So yeah. And check that. Uh-oh. We're wrong. We are wrong here. All right. Well, let's find where we went wrong. So I found where I went wrong. This is a -5. I need to do +5 over here. So that's wrong. Well, let's rewrite this. Noob mistake. So I didn't write it out before. I will this time. So we're going to +5 there and +5 here. Not -5. That's where I went wrong. So -3x. This is actually 15. This is going to give us a much easier fraction later. So let's see. It's going to be -5. And so instead of so divide by -3. Yeah. Instead of -5/3, it's just -5. Joe man, being dumb. See, this is why we do the practice. Ethan, welcome to the stream. So x is greater than -5. Recheck. There we go. All right. This is why we do practice. And then we're gonna move over on our paper here. I'll flip to a new page after this. Okay. -25 is greater than -3x minus 10. We want to get that x all alone, so we're going to +10. Make sure that I'm not making the same mistake as before. +10 to both sides. This -25, well, the negative with a plus, it's actually going to get closer to 0. So, -15 is now greater than... We're going to get this... We're going to get a very similar number as before, aren't we? All right, divide by -3. So that flips because divide by negative. Our x is there. Divide by -3. That's going to just be a +5 because dividing negative by negative, you get a positive. So x is... Oh, that's the other thing. This is kind of backwards here, so we're just going to flip this around and make it easier. Make sure it's still pointing the right direction. Like, we flip it around, it's still pointing at the 5. So x is greater than 5. Check. Hooray! Awesome. Let's continue on here. All right, rewrite the following without an exponent. We're going to learn some new stuff. So this would be a flip because that's a negative exponent. So what are they telling us to do here? So now this is not a fraction. Well, it's not an obvious fraction. Everything's a fraction. It's just over 1, really. So we're going to take our flip here. And remember, everything is a fraction. It's just over 1, and we don't care. So we don't write it as over 1. But really, if we do a flip, that 1 comes to the top. So we do our little flip here. That -9 is put down there. 1 over -9, or -1 over 9. Yeah, if you have a negative in here, it just sort of applies to both. So it just goes over here off to the side. Yeah. I'm gonna flip to a new page real quick. I got this keyboard with my laptop like 4 years. I mean, I got this notebook with my laptop like 4 years ago. Yeah. Okay. Let's do some math here. So, -4 to the -2. Yeah, so we're just going to do a little flip here. Remember, everything is over 1. Everything is a fraction. It's just over 1, which we normally don't write. Yeah, so really, we're going to stick the 1 over the -4. But remember, it's still to the squared. So then it's 1. So -4 times -4 is 16. It is 1 over 16. 1 over 16 is our answer. We'll check that. And it's correct. Next problem. Okay, so we got -3 to the -1. So yeah, let's remember how everything is over 1. Yeah, so that's 1 over -3. Literally, that's all it is. Except, I mean, we're just going to stick that negative at the outside part, basically. So -1 divided by 3. That is our answer. We'll check it. And it's correct. And we continue onward. Okay, so solve for y. Yeah, we saw something pretty similar before. So the fractions here are going to make things real interesting. Let's see how it suggests. So least common denominator, that's the word. Yeah, 2, 3, and 7 is 42. An easy way to go about this is just sort of multiply them all together. It might give you an extra large number that's not like the lowest thing, but it's an easier way rather than trying to find something. Like let's say this was an 8. Yeah, let's say this was an 8. Now I know 24 would be common for 2, 3, and 8, but you know, let's say I spend a long time trying to figure that out. Instead, I just do 2 times 3, which is 6 times 8. That would get me to, 42? Instead of, no. Hold on, 24. That would get me to 48. Yeah, which is twice as big, but I saved that time because I just multiply across instead of trying to figure out 24 would have been the better option. Anyway, oh wow, this is so long I actually have to scroll on it. All right, yeah, so basically, we're going to multiply both sides by this thingy here. So 42 times that. So that's 7 times 42. We could just like multiply the 9 and the 7 by 42 and then simplify down. Or you just sort of pull the 7 out of 42 and you get 6, like it's shown right here. So, yeah. Yeah, you pull the 6 out of the 42, getting rid of the 7 here. So really then you just have 6 times 9, 54 down here. Likewise for these other ones, 42, you pull the 2 out of there, leaves you 21, 21 times 5, and then, yeah, 4, the 3, pull the 3 out, you get a 14. So then you're left with this thing, and then it's just a matter of getting a y all by itself. So you just do your plus 56, you get the 110 there, and you do some dividing, and then some simplifying, and then we're at the solution. So, yeah. Getting a little harder, but still familiar territory for me. So, I'll make a line there. That's old stuff. Okay. So we got -1/2 v plus 3 over 5 -1/3. All right, they gave us some much easier numbers to work with here, I think. Yeah, so first things first, what is the least common denominator of these numbers here? Let's see. If I just multiply straight across, 2 times 5 is 10, times 3, that's 30. So I could just go to 30. I'm just thinking off the top of my head. Yeah, Yeah, 30 is the best number. I can't think of any least common denominator, so we're just gonna multiply everything by 30. Really, it's both sides. Yeah. So multiply that. So negative 1/2 times 30. So yeah, we pull the 2 out of that. Really, it's 15 times negative 1. We have negative 15v plus, all right, we do the same thing for the 5 here. Pull the 5, that leaves us 6, because 5 times 6, 30. So it leaves us 6, 6 times 3, that's 18. That equals, let's see, pull the 3 out, that's 10 left, negative 10. All right, minus 18. We're gonna keep this 15v, but minus 18 over here. Because it's negative, I almost view it as addition, so like 10 plus 18, but it's negative. Anyway, that's 28, negative 28. So then we need to do some more division here. So v equals negative 28 over negative 15, and cross out those negatives, because negative over negative, that's like 1 over 1, which is, anyway, they just sort of cancel out when it's the same over the same. So v equals 28 over 15. Can we simplify that at all? So 28 comes out to 4 and 7. This comes out to 3 and 5. There's nothing in common there. So, yeah. We'll get rid of negatives, and that's pretty much it. So v equals 28 over 15. Can't really simplify that down anymore. That is correct, which is awesome. Okay. Back in my day, me and the math teacher had many a discussion on my ciphering skills, or rather lack thereof. Ciphering, like creating codes kind of cipher, or... Alright. So, same thing here, negative 5/3, negatives, whatever. It's good enough. 7 over 2y minus 9 over 4. Alright, 3, 2, and 4. I happen to know 12 is a common denominator. In fact, I would say it's the least common denominator of all these. But if I just multiplied straight across, 3 times 2 is 6 times 4, that's 24. I could go by 24. It'd be bigger, and then I'd reduce down later. It would come out the same. But yeah, if I just didn't know 12 off the top of my head. We do know 12, though. So, pulling that out, we have negative 5. We pull the 3 out of the 12, that leaves 4. Negative 5 times 4 is negative 20. Negative 20 equals... Alright, and then pull the 2 out, that leaves a 6. 7 times 6 is 42y. And then we have the minus stays there. We have our 4 here, pull that out, leaves a 3. So 9 times 3 is 27. One trick for multiplying 9s that I found is when it comes to like single digits, once you go above 10, it gets weird. Anyway. Yeah, for multiplying 9s, these 2 digits will always add to 9. So 9 times 1, well, that's just 9. It adds up to 9. 9 times 2 is 18. The 1 and the 8 add up to 9. 9 times 3 is 27. The 2 and the 7 add up to 9. That's valid all the way up. 9 times 9, 8 and 1, 81. The 8 and the 1 add up to 9. And then 90, 9 and 0. Once you go above that, then it's not consistent. But anyway, that's an easy way that I do 9s. So yeah. It always adds up to 9 when you add these together. Anyway, I'm getting distracted. Alright, so we need to add this 27 over here. And that's just going to be 7 because it's already, yeah. 7 equals 42y. We're going to divide that by 42. 7 over 42. I'm pretty sure that we can simplify that. We can't quite get it down where we want it, but we can simplify. The Jethro Bodine type of ciphering from the Beverly Hillbillies. I've never seen the Beverly Hillbillies. I've heard of it. I've never actually seen the movie. Yeah. All right. So then this can simplify down. I know I'm kind of getting near the edge of my paper here. Yeah. 7 over 42. So I know this can simplify down because 42 is divisible by 7. So what is it divisible by? 6. 6 times 7 is 42. Right? Yeah, because 7 times 7 is 49. 49 minus 7, 42. So we have 1 over 6 equals y. 1 over 6 y. And that is correct. Nice. All right, we got one more problem here. This one is having me do a bit more. Make sure that I know my stuff. Yeah, I'm trying. Man, I suck at lines. That was disgraceful. Okay. All right, and then got negative 1 over 3 minus 1 over 2 y equals negative 4 over 5. Okay. And what are we doing with this? So let's see, 325. 325. We already saw that 30 was the number to go with. Alternatively, we should multiply them together to get a common denominator. It's not always the least common, but it is a common denominator. So multiply all those by 30. So negative 10. Negative 15 y. 24. A lot of negativity going on in this one. That's all right. All right, so plus 24 is 14. Oh, wait, no, we're doing the wrong direction. Plus 10 is negative 14. Okay. And then divide by negative 15. Get our y equivalent to 14 over 15. That does not simplify down. And this reminds me a lot of this problem up here. It's not too far off, honestly. Yeah, so we have 14 over 15. And just check my work, make sure. So we pulled out the right numbers out of here. That 4 times 6 is 24. Yeah. Yep. Checks out. We'll check this. Correct. Nice. I'm on a learning streak, everybody. I recognize that like half the screen's cut off, but anyway. All right, I'm actually get a new piece of paper. Oh, we're graphing. Yeah, haven't seen graphing yet on my stuff yet. Graphing's fun, although it can be kind of hard sometimes. Okay, graph the line with slope 1/2 passing through the point 5, 5. Okay, so it's always rise over run. So that'd be a rise of 1 and a run of 2. So that means up 1 over 2. How are they doing here? 1, 2, 3, 4, 5. Oh, I get it. So they're starting at 5, 5. So 1, 2, 3, 4, 5. Come up 5, 5, 5. So up 1 over 2, and then you just sort of draw your line from there. Yeah, rise over run. Start at 5, 5. X is the first one. Y is the second one. So 5, 5. Yep. And then the whole 7, 6 thing, you just do a little bit of math. So rise over run. So X is the run, is the horizontal, so that's plus 2. Because it's... Anyway. Yeah, plus 2. And then this 5 here is just plus 1, because the rise, the Y, is just... Anyway. So that's how you get 7, 6, and then you graph it. Okay. Let's see. So, slope of negative 2. So that would mean down 1 over 2. So, I might not even need the paper for this, honestly. So, first we gotta make some points. So, negative 4, 4. So we got a point there. And then we know that our rise, run, whatever, is down 1 over 2. Another point there. We can draw a line, point to point. And that is that. We'll check it, and it is correct. And Halo announcer voice, learning spree. I wish I could sound like Steve. Okay. Yeah, I don't even need my paper for this, honestly. So, -4, -2. And then, oh, apparently we're already drawing our line. All right, whatever. Ooh, so up here, this is important. So slope of -3. Remember how I said earlier, everything is a fraction. It's just over 1. Yeah, so really this is -3 over 1. So that's a rise over run. Rise is -3. Run is 1. Everything is a fraction. It's just over 1. So that's how we get there. So check that. Awesome. I have a feeling we're going to get more graphing right here. What do we got? This is not... Well, this is way different. All right. 243.75 is what percent of 39? Whoa! that's quite a change. Okay. I'm taken by surprise. All right. Percentage problems of means to multiply. What, that times 0.39? All right, how is the saying do this? So, 243.75 is what percent of 39? So that equals P times 39. Oh, so it's what times 39 equals that? Oh, that actually makes sense. What times 39 equals that? Okay. Steve Downs isn't the Halo announcer. He's Chief. Jeff Steitzer is the announcer. Oh, my mistake. I mean, it'd still be cool if I sound like Steve Downs. I could sound like Master Chief. You're right, though. All right. We solve for P to get the answer. So, yeah, we set it up. So, what percent of whatever? That equals P times 39. So then we just sort of, that times P, then we just sort of divide by 39. P equals... Well, this would be way simpler. There's like, yeah, just divide the big one by the little one. Like, yeah, so divide the little one, big one by the little one. And to do that, you set it up P times... Man, they're overcomplicating this a little bit. So 6.25. Now, when it comes to percents, 1 is 100%. 0.5 is 50%. So 6.25, that's 625%. So that number is 625% of 39. So yeah. Okay, I get it now. This one took me for a loop. I was not expecting this because we just got into graphs and then suddenly, what percent is this of that? So 15% of what is 132? All right, see if I can remember this right. So 132 equals P times, I read it as a dot. They just got me in the habit of that in school. Times 15. So 132 equals 15P. So 132 over 15 equals P. Great. Now we gotta simplify this. I'm pretty sure that divides by 3, but this is a little beyond me. We're into the triple digits, so I'm gonna need a little help here. 32. No, we messed up already. 132. Sorry, hit my microphone. Divided by 3. All right, so that's 44. So then we get 44 over, let's see, 15 divided by 3 is 5. And I'm pretty sure that's as far as it goes. 15% of... Did I mess up? No, I think we're supposed to use the calculator because they got it. They got things before. Okay, how about instead 132 divided by 15? We'll just go all the way here. 8.8. There's no good place to put the calculator. 8.8, which is 880%. Oops. Fit a 0 there. Yeah. 880%. That is not correct. Okay. 15% of what is 132? Oh, I'm writing it wrong. 50% of what? Okay. Yeah, so really, we're looking for a big number. 15% of that big number is 132. All right, so what I just did there was 132. I took that times 0.15, which is the 15%. If it was 100%, it'd just be times 1 and it'd get itself. So yeah, times 0.15. Hold on. 132. 132 times 0.15. Am I doing that right? 132 times 0.15. 19.8. Oh no, I gotta divide by 0.15. I think. 880. Oh, I did it right. I just 880. Yeah. I think this is it. There we go. Man, they're throwing me for a loop here. So it's not 880%, it's just 880. Boom. All right, we definitely need more practice with this one. What percent of 27 is 21.6? Okay, what percent of 27? So we're looking for a percent here. Last time it gave us a percent, and we were trying to figure out the big number. This time, we have the percent. No, we don't have the percent. We're looking for the percent. What percent of 27 is 21.6? So, all right. I'm trying to figure out their formula. What I would do here, I think, is 27. No, that did that the wrong way around. 21.6 divided by 27. That's 80%, right? What percent of 27 is 21.6? That's 80%. I'm pretty sure. Yeah, so now I should try actually doing this the way that they're intending. See if I can learn some stuff here. Okay, so 27, 21.6. $420%. Yeah, of course. Maybe it's 69%. I don't know. 27. Like, I know how do I know how to do it on a calculator, but I don't know how to do it on a paper? This is dumb. All right, what did I even do? I feel dumb because I know how to do it on a calculator. So 21.6 divided by 27. 27p. Okay, I think I got this. So 21.6 equals p times 27. So obviously 27p, 21.6 over 27. Yeah. And so then, you know. Okay, so that's how I do it. 21.6 divided by 27 gives us 0.8, which is 80%. I'm just learning some math. Okay, 80%. Let's actually see if that's right. Yay! Awesome. We've done 8 things now. Let's continue onward here. Holy crap! I've been doing this for almost an hour. Hey, back to graphing. I like graphing. Do some parabolas. Parabolas are cool. This is a parabola, right? I think so. Okay. So give all x and y intercepts. We're gonna have like some x squared stuff going on, or maybe not squared, but yeah. So it starts, or it intersects with the x-axis at 1, 0 and 3, 0. It's always going to be something 0 because the x-axis is 0. Let's see. Watching this seems strangely nostalgic. Math streams, woo! Yeah, and then y intersects. We got to come all the way down. We can visually see that it's -3. Trying to math that out sounds like unpleasant. All right, but we can just visually see. So let's hope this works. Okay. This graph function is given below. Let's get some more exciting music here. That's a little better. Okay, so yeah, where's the intersect? So y, follow here, obviously it's -2. And there is only one intersect. X, on the other hand, is going to have 2 intersects, which means we got to use this. I was trying to use parentheses, but it wouldn't. Okay, so x intercepts. We have -4, -2. Easy peasy. We can see visually. That's what it is. Nice. All right, again, visually, there's only one x-intercept, which is -2. And then y-intercepts, we can see that there's just one here, which is -4. Easy peasy, you can see it. Awesome. Now, this has always kind of interested me, because, like, yeah, it intersects at -2, but because of the slope, like, I don't know, it's just like a whole area. This is the difference between engineering and math. Math-wise, it only intersects there. Engineering-wise, there'd be like a whole footprint. Anyway, all right, so yeah, we're doing good. Let's keep going. We're back to percents again. Keiko deposits $500 into an account that pays simple interest at a rate of 3% per year. I'm off screen already. Can I just, yeah, there we go, full screen. How much interest will she be paid in the first 3 years? All right, simple interest. So how often does it compound? To find how much interest is paid each year, multiply $500 by 3%, which is 0.03, which is 15. Cool, 15. So each year, Keiko is paid $15. In 3 years, she will be paid 3 times this amount. Okay, the answer is $45. Simple enough. Okay. Yeah, so 500 times 3. Apparently this is yearly. Oh, 3% per year. Yeah, that makes sense. And she just takes it out. She does not reinvest it. Keiko, you're being dumb. You got to reinvest back into it. Unless you're going to take the whole thing out. I don't know. All right, Jessica. All right, Jessica, what are you doing with your money? Probably bad decisions or something. All right, Jessica. There's some lines here. Jessica's doing $300. And I know that kind of looks like a 6. I do that sometimes. $300 in an account that pays simple interest rate at 6% per year. I realize it's kind of running off the side there. Don't worry, I'll read it for you. $600 per year. Or no, $300, 6% per year, which is 0.06. That probably just looks like a mess right there. Whatever. All right, and then so in 2 years, so per year, 300 times 0.06. We're gonna need a calculator for this. Times 0.06. That's $18 per year. So it's 18. Multiply that by 2. 36. So Jessica is gonna get $36 after 2 years. Jessica, you gotta invest more. That's barely a return. Also, that's a fantastic rate, 6% per year. You imagine investing $10,000, you get $600 a year. Invest $1 million, get $60,000 a year. Like, that's a normal person's wage, you know? I'll be honest, I don't even earn $60,000 a year. I earn way less. Interest goes on the $500. Yeah. Probably talking about previous problem. Yeah, so $300, 6%, $18 in 1 year times 2, because 2 years, $36. Check. Awesome. Yeah, we'll just stay in our same column here. This will be. Oh, here we go. Raphael depositing $2,000. Okay. If you're gonna invest, go big, man. Assuming it's like a safe investment, you know. Don't day trade with a lot of money. You'll lose it. Simple interest rate of multiply times 0.04. And then it's going to be times 6 years. So All right, so 2,000 times 0.04. Yeah, I don't know that off the top of my head, so let's find out. 2,000 times 0.04. That is $80. $80 per year. It's a little bit better than Jessica's investment, although the rate is less. Maybe it's less if you put more in. I've never really invested big amounts. I don't know. So 80 times 6. Is that 480? It is. All right, 480 after 6 years. That's still not like a lot of money. Percent-wise, it's a great return though. So $480. Nice. All right, we're gonna like flip back to graphs. It's weird going between percents and graphs. No, we're back to greatest common factors. That is weird. Okay, let's get this on here again. I'm getting thirsty, but the webcam is on my bottle. What are we doing? So we have 12a cubed minus 9a squared. So we're supposed to factor this out. Oh, okay. This is where things get fun. That quote-unquote fun, and it actually means hard. All right. Greatest common factor of these two, 3a squared. Oh, it says right there. And then factor out the greatest common factor using the distributive property. So that equals 3a squared times 4. Where's this 4a coming from? Why is it times 4a? Oh, is it because that's what's left? Oh, you pull out your 3a squared and 4a is left here. 3 is left. Okay, that makes sense. That makes more sense. And 3a squared. Yeah, so 3a, greatest common factor times whatever's left. Okay, that makes more sense. Okay, so 12c squared plus 9c. Okay, so what can we pull out of here? 3. We can pull 3 out of here. Can't really pull anything higher, so pull out a 3c. That's all we can pull out. So then we're left with, let's see, pulled the 3, so we're left with 4c plus 3. Yeah, so we pulled out 3c, and then the leftovers are just stuck in there. Okie doke. So awkward typing around all my setup. 4c plus 3, close the parentheses. 3c times 4c plus 3. I think that's right. Yay! All right. So the next thing here, 13x squared minus 10x squared. So we got, oh wait, no, I messed up. That's to the third. That's messy, I'm sorry. Okay, 13 is prime number, right? I know that off the top of my head immediately. So we cannot pull any numbers out of here. We can pull an x squared though. So x squared times 13x minus 10. That's just the leftovers. X is hard reaching around everything here. 13x minus 10. Close the parentheses. And I think that's it. We'll check that, which is correct. Awesome. One more should complete this little section. All right, so we're just gonna make a line there. Move this over. We're almost on the edge of the paper. It's fine. Okay, so then we have 10m. I should write this down. Oh, they're sticking the higher exponent on the end instead of being the first thing. 10m squared plus 8m to the third. All right, so 10 and 8. 2 is the only thing I can pull out of that. And then m squared I can pull out of that. All right, then we're gonna do some multiplication stuff here. So I pulled the 2, so the 5 is left. And there's no m left. I pulled the m squared out of that. So 5 plus, that looks like a t, I know. Pulled the 2 out of that, so 4 is left. And then the m, because squared, and 3, and whatever. That's what we got. 2m squared plus 4m. Oop, that's not a 4. Plus whatever. All right. 2m squared times 5 plus 4m. There we go. Hooray! Awesome. Keep it up. Okay. Well, I have been streaming for over an hour now. You know, I'm going to do this section, and then we will reevaluate. Wallamazoo, I came here just to say, use PEMDAS. Oh, we talked so much about PEMDAS earlier. Yeah, man, I got that PEMDAS. Yeah. Okay. Simplify. 9z. Okay, so what's going on here? It kind of draws it out. Honestly, I think it could draw it out better here, though. Here, I'm gonna draw this out because I'm actually unsatisfied with how it has it up here. Okay. 9z 14. Okay. So here, this is the problem you're given, but really, this is what it is. Why do I keep doing the 4 first? I don't know. This is a square root, right? Unless otherwise defined, this is a square root. So really what it's trying to do is it's trying to pull the power of 2 out of stuff. So we'll continue over here. Really what it's doing here is this 9 over here. Really, that's 3 squared. And this is trying to pull squares out. And then z 14, it's trying to pull squares out. So what you end up with is it pulls the squares out, and that gets rid of the whole square root thing. So you're just left with 3z. That's a terrible z. I'm sorry. This 14, it doesn't like... This 14 doesn't get square rooted like the 3 over here. Instead, it just sort of divides it by 2. Then you get your 7. Oh, okay. That's just terrible. We're gonna try that again. 3z to the 7th. Yeah. So, yeah, really, it's just trying to pull squares out of there. That's what's going on there. All right, well, let's actually do some math problems here. Sorry, I just like, I knew that so good, and their explanation I felt was lacking so much. All right, square root of 36. We're gonna have some left behind stuff in this, I think. And then x to the 4th. Okay. So remember how, unless otherwise defined, it's a square root. The problem doesn't say square root, but it's a square root. Keegan defined. I'm not sure why I'm here. Hey, learn some math, Keegan. Yeah, I don't know. This is algebra of some sort. It is in preparation for pre-calculus. So, okay, so back to this. So 36 doesn't easily split like 9 does. That's where we've got to kind of break it down here. So I know I can pull 9 and 4 out of there. Oh, I didn't realize it was 9 and 4. Well, that's easy because we pull 3s out of there, pull 2s out of there. So really, 3 and 2. So this whole squared thing, it's really we got 3 squared and 2 squared multiplied together. So what the squared thing's gonna do, it's just gonna take those squares away. We still have 3 times 2. So I'm gonna come up over here. So we pulled a 6 out, and then this x to the 4 is gonna slash that in half. So then we just have x squared. 6x squared is what we're left with on that. 6x squared. And that's how that works. And this is all above my pay grade. I mostly deal with fractions. Yeah. I mean, this is getting about to the limit of of me. Like, I already know this stuff. It's just sort of review. But awesome. So that's correct. Okay. Now let's move on to the next stuff here. All right, 25z to the 6th, 25z to the 6th, all within a square root. And put that there just to remember it is a square root. Okay, 25. I don't even need to write that. That's easy. Just 5. And then z. Yeah, this one's easy. 5z to the 3rd. Like, boom, easy. Yeah. 5z to the 3rd. Correct. And because I got 2 in a row, I'm done. Okay. So I actually want to return to the home page here. And I want to see how we're doing. 104. That means there's still 104 things to be done. Real numbers is actually getting close to done. How many did we do today? We did 12. Look at us. Yeah. 104 modules. So, yeah. Let's see. Let's do some other math here. Let's see. So, school starts... Dang it. When does school start? I mathed it out. If I do 5 a day, then I'll get things done in time. I don't remember. All right, well, how about this? With 104, if I did 5 a day, how many days is that going to take? 104. All right, that's going to make it a messy number, so I'm just going to say 105, make it easy. So I did 5 a day. That's 21 days, which is exactly 3 weeks. 1, 2, 3. So that puts me in the middle of August, which is awesome. Yeah. 104. And then I actually can't even do a test yet. I have to still do 2 hours of math before it'll let me. Yeah. Okay. All right. So, yeah. How are you guys feeling at this point? Like, I could do more math. I've been streaming. I've been doing math for over an hour now. So, well, here I am gonna take a little break. See if I can extract my webcam. Oh, I'm upside down. Uh-oh. Get upside down Joe Man for a minute. Let's see. There we go. That, by the way, is a deep cycle battery. I was trying to restore it. There's a process you can do with like baking soda and water. It didn't work, but anyway. Yeah, man. Math. I think I'm a little out of focus here, but it'll be down on the paper again probably soon. Yeah, so what do you guys think? I'm down to keep doing math up to the 2-hour mark. Knock out a bunch of this map, prep for pre-calculus. Pretty great. Yeah. I think people are just sort of here to be here. Like, it's not... We're not playing games. We're not having fun. We're doing math, you know? Someone make him do a push-up. Yeah, can we get some donations? Money for math. Oh, man. Most all the math I deal with at work is in thousandths of an inch. It's a weird word. Thousandths of an inch, yeah. Push-ups while doing math. That'd be hard. But I do push-ups for dollars donated. Donate an American dollar, I'll do an American push-up. It's whatever that is. I think it's just a standard push-up. What's with the battery? It's a deep cycle battery. So it looks like a car battery, and the idea is pretty similar. But a car battery exerts a lot of energy all at once to start your car. But it's not the best for like long duration, like a light bulb. It'd still work for a light bulb, but it wouldn't last as long as a deep cycle. Deep cycle probably can't really start your car. It can't deliver that much energy all at once. But a deep cycle battery lasts a long time. So you take the light bulb example, car battery versus deep cycle. And the deep cycle is going to last a lot longer running that light bulb. It's not drawing a lot of electricity, but it's a little bit over a long time. So, Elgao Kriki 1000 CLP looks like that converts to about $1 American. So, yeah. I will do push-up for the approximately $1 American donated. It's telling me $1.1. Wow, I'm in math mode right now. It's telling me $1.10. So, I will do 2 push-ups for you. Also, don't mind the mess. I upgraded my computer and I still haven't cleaned up. I need to take some of these parts and put them in my server. I'm gonna actually focus the camera here. That's better. Right. Ah. Dang it, camera. There we go. Let's do a couple push-ups. I have just enough room, like futon to up there, just enough room. So here we go. 1, 2. There's 2 push-ups. Now I can actually say I did a math stream and got paid for it. Cars and torture chambers use car batteries. Campers and boats use deep cycle batteries, in short. Yeah, basically. Like a motor for a boat uses little enough electricity. It doesn't need a big amount all at once. It's just a little bit for a long period of time running that motor. So, $1 for completing the maths. Yeah. I like that the brightness auto adjusts. Like paper is really, white and bright, so it's like bright, dark, bright, dark, bright, dark. What will it take for Joe to do a one-handed push-up? I'll try. I'm pretty sure I cannot do a one-handed push-up. I'll give it a try. I will give it a try. One-handed push-up. Let's see. It's get that out of the way. I don't think I can do a one-handed push-up, but I'm gonna try a one-handed push-up. So, right arm is the strong arm, right? So, hand behind my back. Ugh, that's as low as I can go, but I know I did not do a push-up. Ugh. Yeah. No, I cannot do a one-handed push-up. Yeah, I cannot do a one-handed push-up. I am not strong enough for that. So, Joe Man discovers shutter speed and white balance. Yeah. Okay. Well, I say we jump back into some more math. Like, feeling good. Nightlife. As a person whom loves math, I'm pretty sure it's just who loves math. Whom is only for indirect objects and sentences. Sorry, learning German taught me these things. As a person who loves math and seeing this, my recommendations, I tapped instantly. Well, Nightlife, I'm glad you're here. We're about to get back to the math. I did like an hour of math and then someone donated $1. I do push-ups for dollars, so $1 American donated is 1 push-up. I'll bet Joe Nana can do a one-handed push-up if only he was around. Yeah, if only. Yeah. Not only is this a math stream, but also a physical education stream too. I mean, honestly, I like math and physics and that stuff. I think it's pretty cool. It's just the repetitiveness of learning the math. It's kind of hard sometimes. So, I used to have a boat, but it lived up to its name and cost me more than it was worth. Was your boat named Black Hole? Ketamex, you are amazing, Joe. Thank you. Thank you, thank you. All right, well, I think let's get back to the math. I gotta set this up again. All right, let's see. Get things in order. New page here. What is your favorite type of math? Simple math. No, I like I do like percents. Goes to show English isn't my strong suit. That's all right, nightlife. Yeah, whom is a real thing, but it's for indirect objects. So like, or is it direct objects? I don't know. To whom am I speaking? In German, they have it. It's turning into a language thing. In German, they have nominative, accusative. I can't remember. Do I have my German book around here? No, it's in a box upstairs. Okay. Nominative, accusative, definitive. Anyway, they have 4 categories. So it would be der, den, dem, des. Anyway, so wer ist das? Who's that? Ich sehe wen. I see who. And then mit wem spreche ich? With whom am I speaking? And it translates over to English because German and English are actually pretty connected. So with whom am I speaking? That is valid. Anyway, I just over nominative, accusative, dative. That's it. And then the 4th category is like of. It's weird. Of the. Anyway. Gute Nacht, mein Freund. Gute Nacht, Valemazu. Yep. Boat means break out another 1,000. Oh, okay. Okay, let's get back to math because even I am not all that great. I'm upside down again. Hello. Okay. Just gotta kind of like wedge this thing in my bottle. Like, I wish I could show you, but since the webcam is the thing getting wedged into the bottle, oh, come on. Hold on. I got this before. Why can't I? I am having struggles. Trying to wedge this thing in my water bottle here. Okay, I think we got it there. Okay. Now, let me make sure this is nice and focused. Here, I need some math to focus on. Okay. That looks pretty focused. Okay. Back to the math. So yeah, let's continue here. And also an English lesson stream. Joe's doing all the subjects. Oh yeah, I could do all sorts of stuff. I also love physics. Okay, I gotta stop. Otherwise, I'm gonna explain how fusion works using the sun. Okay, basically fusion, you squish it enough, usually using gravity, and energy pops out. That's how the sun works. Sun's really big, squish it, energy pops out, sun's really bright. Okay, let's get back to math. I do genuinely love science. I think it's really cool. Everyone should learn science and like. Anyway, okay, math. Why am I using a pencil? Get out of here. Use a pen. So, find the surface area of this rectangular prism. Be sure to include the correct unit in your answer. So, centimeters. We got to make sure we use centimeters in the answer, not inches, because inches have nothing to do with this. Unless we converted. That'd be weird. If these streams turn into a regular thing, it might be worth it to get one of those desk mount mic arms to put the cam on. No, I do actually have something. I just don't know where it went. Yeah. Yeah, I do have something. I just don't know where it is, but it would be perfect for this camera. Anyway, I'm not sure if I even need to write anything. Let's take a look here. So we have our prism, rectangular prism. We have our box. I'm gonna call it a box, even if it's not like the most accurate way of referring to that. Yeah, so we got our box here. So to find the surface area, oh yeah. So like we know this is 9, and we know it's a rectangle, so it's gonna be the same on the other side. So 9, and we know it's 4 tall, so 9 by 4. We know that side's gonna be 36 centimeters squared. Yeah. And then similar thing, 8 by 9, 72. Okay, yeah, simple enough. So then, to find the surface area of... Oh, I get it. You find the 3 sides, and then you multiply them all by 2, because they all have their opposite sides. So, multiply them by 2, add them all up, you get your surface area squared. Okay. This one's going to have a lot of writing, mostly just keeping track of all the sides. Okay. I'm going to move this over a little bit because they centered this for some reason. Let's see. Well, that kind of works, but... I don't know, man. Like, it's kind of big. Doesn't give me a lot of room to work here. I'm just gonna move that right there. That still gives me enough. That gives me enough room. Okay, so we gotta find the surface area of this whole thing. So that first face is this big flat front of it. So 7 times 8 is gonna be one of them. I can also just find the surface area of 3 sides, multiply that by 2, instead of multiplying everything by 2. Alright, and then the next side, let's see, we'll go with the bottom, 8 by 4. 8 by 4. And this is inches. I'll just... Yeah. That's inches. I'll just remember that for later. We got 7 by 8. We got 8 by 4. 8 by 4 is the bottom. 7 by 8 is the front. So bottom, front. Then we need the side, which is 7 by 4. And I forgot my parentheses. Okay. So what we can do is actually add all that up and then multiply by 2. Or we can multiply all these by 2. I'll do it one way and then do it the other way in a minute. So 7 times 8. I happen to know that is 56. And then 8 times 4. 8 times 2 is 16. Okay, 32. And then 7 times 4 is 28. 28. All right. And then they would have me multiply all these by 2 right now. So this is going to be 112, 64, and 56. Add those together. Let's see. I'm going to do this in my head. So 112, 64, 116 plus 60, 176. Plus 56. Add the 6, 182, 232. 232 inches squared. Yep. 232 inches squared. Let's see if that's right. Hooray, it's right. You know, what I should do actually is just like extend this all the way so I can look at... Hold on. Oh, I can give it gray area? Oh, that's kind of cool actually. Oh no, it's because the gray's already there. Okay. Anyway, I'm getting distracted. So we got that one right, which is awesome. Go to the next one here. All right. Find the surface area of this cube. Yeah, same deal. So let's figure out the cube. All right, so we get 8 by 8 by... Okay. Well, I'm just going to skip a step. I happen to know 8 times 8 is 64. So we got 64, 64, and 64 on all the sides. And we're going to multiply all those by 2. 128, 128, 128. Sorry, big numbers. I just multiply it by 3. 384. Just taking some shortcuts. 384. And let's not forget our thingamajiggy. Feet squared. Square feet. 384 square feet for the surface area. Awesome. Keep it up. Well, let's continue on here. About a half hour. is when I'll call it. 2 hours of math is probably good enough. Let's see. All right, so now we're all about simplifying again. All right, so this 5 up here is gonna have to spread into these things. So as you can see down here, it's all in parentheses, but you sort of break it up. This 5 applies to both, and then everything gets a 5. This 2 gets a 5. This squared gets a 5, and they kind of skipped a little bit here, but that turns into a 10. 2 to the 5th is 32. 10, or x4, 4 times 5, you get 20. Then you get a big old number here. Yep, simple enough. All right, I need to show some workbook here. So let's see. So we got big old parentheses, z to the 3rd over, also that's 3. I don't know, sometimes I don't really work in a straight flow. I just sort of fill it in here and there, and yeah. Alright, so this 3 is going to apply to everything. So this z to the 3rd, that's actually going to multiply, so it's z to the 9 over 2 to the 3rd, so that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 8x squared, 3 to 8 to the 6th, z over 9, or I mean z to the 9. Let's see, z to the 9, all that over 8x to the 6th. Hooray! Surface area is coming back to me now. I forgot how easy they were. Yeah, surface area is really not bad. It's when they start doing rhombuses. Is this a rhombus or an no, okay. Definitely not an icosahedron. Yeah, when they start doing stuff like this, and then you got to figure out, these ports. No, that's when stuff starts getting hard. All right, so let's continue onward here. A squared over minus 2b to the 5th. And that 5 is going to apply to everything, so you get a to the 10. This negative 2. Ooh, okay, so 2 times 2 times 2 times 2 times 2. That's what we're dealing with here. I know this is 32, but I'm just going to write it out anyway. Okay, so 2 times 2, 4, 8, 16, 32. And, little trick here, this is a negative 2. If this were a positive, if this were an even number, like a 2, negative 2 times negative 2 makes it positive. 2 negatives make it positive. An odd number of negatives keep it negative. So this is still going to be a negative 32. Negative 32. And then this b is just going to grab the 5, because remember, everything is a fraction and everything has an exponent. It just happens to be an exponent of 1. Noah Mahali, have you ever played Dark Souls Remastered? Remastered? I haven't played either. I've never played any Dark Souls. All right, let's type in our answer here. Yeah, that can't be simplified. Always check if it can be simplified. Otherwise, the program will yell at you. Alright, and then I realized as I was inputting this negative here is going to go at the beginning of everything, because that's just sort of how negatives work. Hooray! Hip hip hooray for Jordan! Yay. Alright, what do we got? Alright, we're going... we're just going left field here, completely unrelated to what we were just doing. So, classify each number below as an integer or not. Okay, what is an integer? I know there's different classifications as numbers. Integers. Okay, so an integer is it's a whole number, but it could also be a negative. You know what? Surely there's a Google. There's like a Venn diagram. Oh my goodness, I said Google, and my phone's like, oh yeah, what do you need? Okay. Reaching around my microphone here a little hard. Whole number Venn diagram. Okay, yeah. So when it comes to numbers, okay, I like this one. It's an image. Credit to Brainly.com. All right. Yeah. So all right. So natural numbers 1, 2, 3. Whole numbers really branching out with this one. 0, 1, 2, 3. Yeah. So natural numbers is anything above 0. Whole numbers, anything positive, and also not decimal or anything crazy. Integers, we just take that. We also include the negatives. And then rational numbers that's where we get into like 5.5, like smaller than whole numbers. Okay, so this is what we're working with. Seriously, remember this. Like, yeah. All right, we're getting distracted. All right, so back to this. All right, so integers are those. So is this an integer? -3/1. Remember, everything is a fraction. It's at least over 1. So really, we can get rid of this over 1 thing. It's just -3, guys. So yes. Oh, I can't actually answer this. Okay. Because remember, integers include all the negatives. It's the whole thing. Just, it doesn't break down into smaller than a whole number. It's weird to say that because a whole number, you know what I mean. Yeah. So really, this is just -3. That'd be yes. This is a crazy fraction. That's no. This has a decimal, so that's no. This is just a negative. Yes. And this is just a very nice 43. Yes. All right, is that how it breaks down? Yes, no, no, yes, yes. Okay, I got this. All right, so is it an integer? 13? Of course. No, you're too crazy. You're too crazy. Hey, you're fine. And negative. Okay, okay, they're tricking us here. -12/4. We simplify that to just -3. So yes. Yeah, that was a little trick there, thinking, you know, oh, fraction, da da da. But we can simplify it so that it is no longer a fraction. So yeah. Okay, continuing on here. So 18/3, that's just 6. -88, that's an integer. Nah, you're too crazy of a fraction. You're too crazy of a decimal. That's just -7. Yay! And that was pretty easy. Absolute values, hooray! Absolute values, whatever's inside, it forces it to be a positive. This is antidepressant drugs. It forces you to be positive. Okay, so absolute value of x plus 10 equals 20. Also, with absolute values, you can get 2 answers because sometimes, you know, it's like this is the answer you'd get with this being a positive. But if it wasn't a positive, this is also the answer you could get. Yeah, so here, -10, move it over to that side. Absolute value of x equals 10. So it's kind of like, yeah. Absolute value, okay. So it could be either way. Because like, let's say, okay, I don't know. I don't have an example off the top of my head. But yeah, x equals 10 or x equals -10. Because, okay, yeah, now I get it. It could be either one of these because you stick a 10 in here. Well, 10's equal to 10, obviously. You stick a -10 in here. It gets absolute valueified, makes it positive, and then it's still 10 equals 10. So yeah, that makes sense. Okay. I can do this without even writing. All right, so 13 minus 6 is going to be 7. So y equals 7, or it could be -7. Hooray! All right, next one. Ah, -3 absolute value y equals 0. This is a little bit of a crazy one, because I would think -3y, it's only the y that's absolute valued though. So I think what we have to do is divide this by -3. The problem is 0 divided by anything is still 0. Actually, if you divide 0 by 0, it's just undefined, which technically is not a number. Anyway, so -3. It's not like it's plus either. Is this no solution? Well, hold on. -3 absolute value y. Let's just, for fun, what if y was a 3? That'd be -3. I think this is no solution, but let's see. I'm just going to plug a couple numbers in to see. So -3 times 3 would give you 9. Now, actually, hold on. Oh, y has to be 0. Yeah, so -3 times 0 equals 0. That's the only way that this comes out. I think that's the answer. And there's no positive and -0, it's just 0. I think that's it. Yeah, okay. So I guess I could have mathed this out. I could have divided by -3. 0 divided by -3 is still 0. Y equals 0. I could have mathed that. Okay. Learning streak. Woo! Am I going to need my paper? Ooh, triangles. All right. Right triangles. Okay, this is fun. We're going to find the hypotenuse. Side length x. Yes, that is the hypotenuse. It's a fun word to say. Okay. This is a squared plus b squared equals c squared. Okay, I love this. This is the Pythagorean theorem. Yeah. I love the Pythagorean theorem. Mostly because it says pi. Alright, so what do we got here? So we got 12, 10, and what is x? So a squared, b squared, c squared. So boom, 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 that equals that. And then, flip it around, so x squared equals that. But then we don't want x squared, we want x. So square root, x comes out fine, but 244. Oh, wow. They broke that down into... rounding to the nearest hundredth, we get that. They decided to go to the 10,000th. Okay, so this is an interesting time where they want a decimal instead of that. Okay, so now we know how to do that. So how are we gonna break this down? Time to use some paper. Oops. No, what? No, go away. I clicked into OBS and it's like, oh, what do you want to do? I want to use something that's not you. That's what. Okay. What are we doing? We got a triangle here. So A is always the littlest side. So in this case, A is x. B is the middle sized. So A squared plus B squared equals C squared. So x squared plus 64 equals 81. We got a minus 64 off of that, so x squared equals, let's see, minus 4, it's 77. All right, 17, which is a prime number, so this is not going to go well. So x equals square root of 17. It wants the answer in the nearest hundredth. So square root of 17. This is absolutely calculator territory. So let's see. 17 square root 4.123. Wait, no. So 100th, 4.12. Yep. It is absolutely calculator needed. 4.12. Yay! All right. Next problem. We'll do math for about another 10 minutes. Yeah. So let's see. So 7 is the smallest one. So a squared plus b squared equals c squared. Ugh, my writing sucks. Is x squared. Add these together. What's that? 153, 193. Alright, we're just gonna square root a couple of these things. And yeah, we need a calculator for this one. So 193. Square root that. 138. 92. I mean, I don't know why I said it that way. 13.89. Round your answer to the nearest hundredth. Well, 892. The 2, it's low enough. We don't round. So, 13.89. Hooray! You crushed it. Oh, it's cut off. You crushed it, Jay. Okay. Well, I think let's do like 1 or 2 more. We're getting near the end of the stream, and I've been doing math for like 2 hours. It's good enough. For each point in the table below, decide whether it is on line 1, line 2, both, or neither. So first we gotta figure out the lines. All right, how is it saying we should do this? So line 1 is that formula. Oh, I get it. You plug in the x and y and okay. Basically, does it equal 27? So this first one, 6 and 7. 6 times 6 and 5 times 7. That does not equal negative 27. And then line 2, plug those in as well. It does not equal negative 19. So they're on neither. Okay, so does it fit line 1? Does it fit line 2? This one fits line 2. This one fits line 1 only. So that makes sense. Okay. We are gonna we got room. We can keep writing this down. Sorry, the webcam cord is getting caught a little bit. Okay. What's math? So we're working with 7x plus y equals 5 and negative x minus 3y equals 5. Alright, so first we have 6 and 7. So if I plug a 6 in, 7 times 6, that's 42 plus 7. Does that equal 5? Most definitely does not for line 1. Plug it into line 2 here. What was that again? So 6 and 7. Alright, so negative 6 minus, let's see, and then with the y was 7 minus 21. Does that equal 5? This is not even close. Alright, so this first one is neither line. And then we get to figure it out for the other ones. This is going to be slow. Yo, Joe, it's Ajax. What's up, pimp? Milwaukee Slush. Hello. Nightlife. My Wi-Fi decided to die. Did I miss anything? I don't know at what point you might have dropped out. Looks like it was only the last few minutes, though. So, you just missed some math, you know? Okay. All right, so now we got to figure out these other lines. We'll draw a line there just so we don't get confused here. So 1 and negative 2. It's going to be 7 plus negative 2. So 7 minus 2 equals 5, which is true. So for line 1, that is correct. And then, let's see, 1, so negative 1 minus, let's see, 3, so minus 3, negative 2, so negative 1 plus 6 basically. That is 5. So yeah, the second one is both lines. All right. And then for the last one, 0 and 5. 0 plus 0, because 7 plus y, like both of them get filled in with 0. Like, oh wait, no, that's a 5. Okay, let's just try this again. So 7 times 0 is 0, plus the y gets replaced with a 5. Does that equal 5? Heck yeah, it does. And then, let's see, negative x, so still 0, minus 3 times 5, that's negative 15. Does that equal 5? Heck no, it does not. Okay, so this one, only line 1. Hooray! That was correct. For each point in the table below, do same thing. I need a new page, so we're just gonna flip. Position this just right. Okay. 2x plus 7y equals 24. Wow. Those 2's and 4's are not proportional at all. 3x plus y equals 17. Okay. So what are we working with here? I'm actually going to write them down here. 5, 2. Probably, I'm going off a little bit here. 4, 5, and 0, 7. Okay, so for the 5, 2, we stick the 5 in there. So we got 10 plus 14. Does that equal 24? Yeah, it does. And then, let's see, got 15 plus 2. Does that equal 17? Yes, it does. All right, I might run out of space here. All right, then we got 8 plus 35. I got that right? Yeah, there's no negatives going on here. It's all positive. 8 plus 35, does that equal 24? No, it does not. That just looks like 24x. There we go. And then 12 plus 5. That does indeed equal 17. And then last one here, kind of running out of room on the paper. Let's see, 0 plus 49. Does that equal 24? No, it does not. And then 0 plus 7 equals 17. No, it does not. Okay. The first one, we've got both lines. We've got line 2 and neither. Hooray! I'm on a learning streak. I'm on a learning streak. All right. We're going to do one more. We're trying to get my finger in frame here. We're going to do one more. One more module. So it's going to be like 2 or 3 problems. Last one. What do we got? Oh. Bro, this is going to go so quick. All right. So, square root of 36 over 49. Well, that's 6 over 7. No, that's 6 times 6 over 7 times 7. So that's 6 squared over 7 squared. So we pull 6 over 7 out of it. Okay, simple as that. Yo, Joe. Oh, I read that comment already. Bro, I don't even need paper for this. Like, 16 over... That's just 4 over 5. Bruh. Get at me. Okay, well, now we're dealing with not so pretty numbers. So, got 20 over 45. So, let's see what we can pull out of here. We can pull a 4 and a 5. That splits into 2 and 2. And then the 45, that splits into 9 and 5. 3, 3. So what we have here is 6, because 2 times 3. That makes its way out, but the 5 and the 5 are left behind. But it's Oh. Oh, now that is interesting. Okay. 5 over 5, that's 1. Well, square root of 1 is 1, right? Because 1 times 1... Is this just 6? So, the weirdest way to write 6. No, it is not correct. Okay. So we pulled the 9 out. Oh, I know what I'm missing here. I multiplied these two together. That is incorrect. This whole, like, 6 deal? No, that should be 2/3. Yeah. It's still 2 over 3. There we go. Yeah, they do not multiply. They are fractioned apart. Okay. We'll keep going here. I think this might be the last math problem. Ah, and it's an easy one. That's 6 over 8, which is 3 over 4, because it simplifies. 6 over 8, 3 over 4. Yep. Nice. And... hold on. Oh, no! We can't stop there! 19 topics learned. We have to go for 20. High score! Now, wait. I can't just stop at 19. I gotta do 20 now. I have actually been doing math for 2 hours now, so that's cool. Alright, so, what are we doing here? So, solve for y. A bunch of complicated stuff. Multiply this by 10, and then you have 90 equals the thingies without denominators anymore. You pull y out of it, and okay. 6v minus 4 over 5 plus 5v minus 8 over 3. Okay, so 15. Just multiply this whole thing by 15. So 8 times 15, that's 80 plus 40, that's 120. I've done a lot of practice with like quick math like that, so. Alright, and then pull the 5 out of that, so 3, so it's 18 v minus 12 plus, pull the 3 out, so it's 5, so 25 v minus 40. Alright, then we just sort of math it out from here. Brian Leno, love this. Much love to Joe Man, you got this, we believe in you. Thank you, Brian. Oh, Bryden Leno. I missaid your name. Bryden Leno. Okay, so yeah, we just gotta math this out. So 18, let's see, stick this here. So the 18 and the 25 go together. What's that? 33, 43, 43v. This 12 and 40 go together, and even more negativity. 52, it's 120. It's waiting for its moment. The moment's gonna come soon. So plus 52, 172 equals 43v. I have a feeling that 43 is 172 is going to divide by 43 easily. Yep, it's 4. Sorry, calculator got off camera a little bit there. So 4 equals v, or you know, v equals 4. Cool. Check that. Correct. Okay, here we go. The actual last math problem. Because this should put us at 20 modules learned tonight. 20 modules over 2 hours. What's that? 120 minutes. 6 minutes per module. It's pretty good. Okay, so u plus 1 over 6 minus 7u minus 4 over 3 equals -5. Okay, so 6 and 3, that's 18. Except, I don't need that big number because we can just multiply by 6. This will get doubled. This will just sort of pop out. So, yeah, least common denominator instead of just any old plain common denominator. Multiply by 6. So we'll have u plus 1, and then pull 3 out of it. We still got to multiply it by 2. So 14u minus 8. And then this 5 is going to get the full force of that 6. So negative 30. And then we just math this out. So u minus 14 is negative 13u. I wrote that a little bit weird. And then 1 minus 8 is negative 7. It's a lot of negativity right here. I'm just going to multiply it all by negative 1 because why not? These are equivalent. I just multiply by negative 1 over negative 1. Anyway, it equals out. So instead of this negative 7 plus, which would be, that get to negative 23, now it's just going to be 23. So 13u equals 23. That's not gonna come out very nicely. So u equals 23 over 13. Looks like we're going with fractions here. It doesn't say anything about rounding. Oops. 23 over 13. I'm just going to check my work. Let's see. Yeah, that's it. And uh-oh. Okay, well, we clearly did something wrong here. Let's figure out where we went wrong. Alright, so we multiplied everything by 6. I have a feeling this 23 is somehow supposed to be like 26. Let's see, so u, that does give negative 7. That gives negative 13, right? This is a little tricky, actually. Here, let me think on this one. I think what happened here is this 14 here took the full force of this negative instead of it being split to the 8 here. So what if we write it as all right, u plus 1, no doubt there. Nightlife, heck yeah. Thanks, Joe. You've helped me refresh my brain for the year of school that starts in like 2-3 weeks. Hey, awesome. Get a little head start when school starts up. All right, I think I went wrong here. So I think it's more like that. Yeah. So then the 6. So we multiply everything by 2 here, and then this negative. So this should be a plus 8. That's what's going on here. So it's still minus 14u. I'm doing my u's differently. It's weird, I know. So that should be plus 8 equals negative 30. A little tricky. Are you going to do more streams like this? I mean, I could. Be kind of weird if I became known as the math streamer, but you know, I got a $1 donation, so better than some streams I've done. As a 10th grader, going to 11th, what am I looking at? This is preparing for pre-calculus. Yeah, I don't know what math class you're going into, but this is preparing me for pre-calculus. Also, Bardock Vegetable, welcome to the stream. Creeper128 Pat, and oh, Bryden Leno, you were already here. Okay, yeah, so I made a mistake. This was incorrect. Really, it should be plus 8 because that. Okay, so it's still negative 13u, but this is going to be a 9 instead. Is it a 9? Plus 9 equals negative 30. It's going to come down to negative 21. Oh, wait, no, hold on. That'd be minus 9, so 39. There we go. Oh, and then, okay, that's easy, yeah. So then v equals 3. Man, 3 is a lot nicer number than what I had. All right, let's recheck this. Correct. All right, we gotta do one more. Gotta do one more problem here. Prove that we know. It's not too bad. It looks weird now, but it'll make sense. Yeah. Okay, so we got a little more room on our paper here. I'm hoping we can get this without having to flip a page here. Okay, so we got 9w plus 9. Also, the music stopped. Come back, music, please. Okay. 9w plus 9. I always write it out because it just makes it easier. Okay, sticking these on either side now. Yeah, they're up in their game. Alright, remember what I said. Everything is a fraction. So really, boom. Alright, that probably won't actually matter. But anyway, we're going to multiply this whole thing by 6. But we got to remember, in reality, it's kind of like this. All these are multiplied by 6. So pull the 2 out. So it's 3 times that top row. 18w plus 18. No, I did that wrong. That is 27w plus 27 equals, I pull the 3 out, so the 2 is left. 14w minus 12 plus, and there's nothing really pull out there. So yeah, 6 times 26, full force. What's that? 120, 156. All right. I know it's a little messy, but that's what we got here. Looks like algebra with extra steps. That's basically how all math works. It's just math, but with extra steps. You're the only guy that can pronounce my name right. Really? Your name's not even that weird. Bryden Leno? Oh. Okay. Alright, back to the math here. So, 27w plus 27. Alright. So the first thing, this 27, I want to move it over there. So 27w equals, so minus 27. Yeah, we're gonna hop on bandwagon. So we're already negative 12 here, which is gonna come out of this 156. So 156 minus 12, 154, 144, and then minus 27. So 144, 137, 117. 117, awesome. And then we gotta get rid of some w's here. So minus 14w, it's gonna drop this down to 13. 117. Ooh, does that math out nicely? I don't know, 13 is weird. 117 divided by 13. Oh, that gives us 9 actually. So that does math out pretty nicely. W equals 9. Alright, let's see if this is correct. W equals 9. Check. Woohoo! And I think, yes. 20 topics learned. Man, we made so much progress tonight. So much. Alright, well, that's going to do it. I've been doing math for 2 hours, so. Alright, return to home page. Wait a second. This number got bigger. This wasn't 112 before. It was... Hold on. Can I look back in the stream? Yeah. I'm going to find it. Okay, hold on. Yeah, it was 104 an hour ago. It was 104. Why do I have more to learn now? Bro. How am I supposed to plan How am I supposed to plan things when you're changing your number? Alright, well, obviously, we need to fill up this pie. Well, we did learn about whatever this section is, functions and graphs. Learn some of that. 112. That is higher than it was an hour ago. Somehow I have more to learn now. Alright. Okay. Well, let me set my camera back up. Here, I'll yeah. Hello. Camera back up here. Watch this. I'm going to magically flip. Whoop. Yep. Okay. We just did 2 hours of math. So there's that. This almost got as much attention as my normal streams too, which is concerning. Either I'm good at entertaining regardless of the topic, or I'm not good at entertaining when I get to choose what I do for streams. Alright. Lots of talking. Always gotta drink water. So, well, that's gonna do it for tonight. 2 hours of math. Plenty. Learned 20 topics, and I apparently have almost as much to do as I completed. Just weird. Yeah. I'm gonna keep this notebook. If we do more math streams, which would be weird, but if we do more math streams, then I can just keep writing in the book. A little hard to grab the cover here, but yeah. This came with my laptop. Handy notebook. Yeah, we're gonna start closing out the stream here. There's a certain song I play. Let me find it here. Yep, there it is. Okay, alrighty, that was quite educational. You should do more subjects on streams. Going to school with Joe. Yep. That it was. Alright, yep, so my calculator away. Oops. Should I put this on the stream shelf here? Is it a math stream? Put my pen and pencil up there. Yeah. There's also a plastic bag. That's just garbage. Okay. Well, I think it's time to end out the stream. So, thank you everyone for watching. A little bit of an odd stream. Link in the description to my Discord if you want to be, you know, the most up to date. You could also subscribe and hit that notification, but whatever's most convenient for you. Stay up to date on what I'm doing, what I have coming up, and I do have my Friday stream still. This does not replace it. This is just a side thing. So I'll hopefully see a lot of you on Friday, 7 p.m. Mountain Time.